Today we're going to talk about the rules for differentiation. And it's a very exciting day in calculus because you know that limit rule that I've been making you use for the past few days? You only have to use that limit rule now if I tell you to. Okay, these are some very, very important rules. Derivative of a constant. Remember, derivative means slope, so the slope of a constant line is 0. Memorize this rule. The power rule, this is super important. To take the derivative of some function, you bring down the exponent, and your exponent is reduced by 1. And what you can do, a constant multiple rule, is basically you can just bring the constant out in front and then take the derivative of the function as is. You also have the sum and difference rule, where basically I could just distribute the derivative to each one of the terms, whether you're adding or subtracting. And we're going to get to what happens when you're multiplying and dividing here in a minute. But let's do some examples involving this. Okay, so derivative of each function. So what I can do to find my derivative, bring down the exponent in front and multiply it to that constant. So 4t, reduce that exponent by 1. Bring the exponent down, so that's just 3 times 1. T to the 0 power is 1. Derivative of a constant is 0. For this one, what I would recommend we do is we write this to the 1/4 power, and you write any exponents that are in the denominator to the negative power. So then when we take our derivative here, bring down the 1/4, reduce your exponent. 3 times 5 is a 15. Reduce your exponent. 5 times 7 is a negative 35. Now reducing this exponent by 1 gets me a negative 6. In this example, we have the product rule when you're trying to take the derivative of two functions and they're being multiplied together. So that equals, leaving the first one alone, derivative of the second, plus leaving the second one alone, derivative of the first. And obviously these two terms can switch spots depending on the teacher, and then you want to make sure that you always simplify. So okay, if you look at this is f, and this is g of our function, derivative of h of x. Okay, so h prime of x is equal to the first times by the derivative of the second, plus, leaving the second alone, derivative of the first. Okay, so we take our f of x, which is just regular old 3x minus 2x squared, times by the derivative of the second, which the derivative of just this function is 4, plus, leaving the second alone, plus 4x, derivative of the first, which turns into 3 minus 4x. So then now we have our derivative distributing through the 4, we get 12x minus 8x squared. Now you want to FOIL all this out. Luckily there's a plus sign in the middle, so I don't have to worry about distributing a negative. We get a 15 minus an 8x, and then minus a 16x squared. Now we have to simplify, combine like terms, and write it in standard form just so that it makes it easier on Mrs. Marnell the grade. Negative 24x squared plus a 4x plus a 15. Now your quotient rule. So if you have two functions and you're dividing, how I remember this is low d high minus high D low, draw a line, and square the below. Don't forget to square it. I often forget to square it. First time I was recording these videos, the students got really upset with me because I kept forgetting to square the below. Okay, so finding the derivative of this. If this is f and this is g, you might want to, the first few times, be writing it out. Low d high minus high d low, draw a line, square the below. And what might be helpful to you guys is over on the side, if you make a little note to yourself, f prime is equal to 5, g prime is equal to 2x. That's going to make your life actually a little bit easier. Okay, so low d high, which is 5, minus high, which is 5x minus 2. D low, we have that as 2x. Draw a line, square the below. Okay, so simplifying that, I'm going to go through this kind of quickly because that tends to be the boring part of the videos, but that's often where I make my mistakes, like right there. And I have a plus a 4x all over the denominator squared. And so then I end up with a negative 5x squared plus a 4x plus a 5. And then we have an x squared plus 1 squared. Okay, writing the equation of the tangent line for a function. Remember, a tangent line, what you need is you need a point, so 1. When I plug in 1 for every x, I'm not going to show that work, that's a negative 3. And we need the slope. And again, I like to plug into y minus y1 equals m times x minus x1. To find your slope, take your derivative. Okay, derivative of the first. Leave the second alone, plus leaving the first alone, plus leaving the first alone. Derivative of the second is 1. Okay, so now f prime of 1, so you plug in 1. So I have a 3 minus a 3. And I have a 1 plus a 2. I have a 1 plus 3. Oh, this should be a minus. Minus 3 plus 1 times by a 1. And that simplifies to be a negative 1. So again, plugging in y minus y1 is equal to m, which we just found, our slope of our tangent line, x minus x1. Okay, second order and higher order derivatives. So our notation for the first derivative is just the derivative. The second derivative is this notation right here. You need to understand what that notation is. The second derivative of y with respect to x. And the third derivative. And then the nth derivative. That doesn't mean we're squaring the derivative. It means we're finding the derivative of... So the second derivative is the derivative of the first derivative. The third derivative is the derivative of the second derivative. Okay, so finding the first four derivatives. Bring down my exponent, reduce your exponent by 1. Bring down the exponent, reduce your exponent by 1. Bring down your exponent, reduce your exponent by 1. I'm just going to do a quick check to make sure I did that right, and I did. So now your second derivative, you take the derivative of this function. third derivative. Take the derivative of this function. And then the fourth derivative is that. Now this is our last question, and this is a very, very, very popular question. So you have to find f of 2, and they give you a bunch of different function values and their derivatives. One thing I want you guys to make sure you're showing me is take the derivative of this, f prime of x. Show me this step of taking the derivative of g of x and the derivative of h of x. Now show me the plugging in of 2. Now, okay. So I have 2 times g prime of 2. G prime of 2 is a negative 2 plus h prime of 2. H prime of 2 is 4. So this all simplifies to be a negative 4 plus 4, which is a 0. Now for the bottom one, you can't just take the derivative of g and h. Remember, it's our product rule. Derivative of the first, leaving the second alone, plus leaving the first alone, derivative of the second. Now plug in. Okay, so this equals g prime of 2 is negative 2. H of 2 was a negative 1. G of 2 was 3. H prime of 2 was a 4. So we get a 2 plus a 12, which is 14. Okay. Please make sure your Google form below this video is submitted on time.